number 2 is saying, given an array B, break it into k sub-arrays in a way that maximum sum of all the sub-arrays comes out to be minimum. So it must be a little trickier to understand. What I will do, based upon the example which is given to us here, I will be explaining it to you in the simpler language. Alright. So let's just write down it here. So let us say your array is something like 1, 2, 3, 4. Then they are saying k is 3. So what they are saying, they are saying that whatever values which is given to you, you have to break it into k sub-arrays. So break into k sub-arrays. Alright, and after that, what you will be doing from those sub-arrays, you have to find out the sum, and that sum has to be minimum out of all the possible combinations. So I'll write it here. So first is to break it into k sub-arrays. Then the second thing which you will have to do is find out maximum sum from all sub-arrays. And what you have to do, you have to pick sub-arrays in a way that they return minimum sum. So you must be confused. Firstly, we are talking about maximum sum, then we are talking about minimum sum. That is because in some, like what we have to do when we are breaking it down, obviously from every sub-array, we have to find out the sum, and that sum has to be maximum. Like that one we are going to pick. But we have to break it down in a way that we are getting the minimum sum. So if you are going to break it down, like I'm going to take some examples. If we are going to break it down, possibility is there that in some of the cases you are not going to get the minimum sum. So what you will do, out of all the combinations, you just have to pick that one which is going to return you the minimum sum. So now if your k is 3, what we will be doing from this one, how it can be there. So one way can be, like in one sub array you just have 1, in second one you just have 2, the third one you just have 3. What the other one can be, you have 1, you have 2 and 3, and then you have 4. What the other combination can be, you have 1 and 2, you have 2, you have 3, and then you have 4. Now these are the sub arrays. So this is your one way of partitioning, this is your second way of partitioning, this is your third way of partitioning, right? From this you have to calculate the sum. So if you have one element, what is going to be the sum for that? 1. If you have just 2 element, what is going to be the sum for that? 2. If you have 3 and 4, what is going to be the sum? 3 plus 4, that is going to be 7. Then if you have 1, and out of 1, 2 and 7, what is going to be the maximum sum? 7. Correct? If we are observing this example, what is the value here? 1. Then we have 2 and 3. So what is going to be the sum for that? 2 plus 3, that is going to be 5. Then you have 4. Now out of 1, 5 and 4, you just have to pick a sum which is maximum. So what is the maximum sum? 5. Then we are going to take this example. So here what we have, 1 and 2. So that is going to give you some 3. This is going to give you some 3. This is going to give you some 4. So now we have 3, 3, 4. Out of this, what is the maximum sum which you have? That is 4. Out of these 3 combinations, what do you have to pick? You have to pick the one which has minimum value. So now the minimum and maximum will be clear to you. So what we have done, firstly we have done the partitioning. Then from these set of values, what we have done, we have picked them, like from every set, what we have done, we have picked the maximum sum, and out of all these combinations, which we are going to conclude as the result, the one which is going to have the minimum sum value. So here, this particular one has the minimum sum value. So I hope question must be clear to you. Now I'm just going to tell you the approach which we are going to use here, and then we are going to move into its implementation. Okay. So in order to achieve it, what we are going to use, we are going to use binary search. So if we are going to use that one, if you have to find out the minimum sum, what is that going to be? The minimum sum is probably it can be 1. And what is going to be the maximum sum? Maximum sum is actually going to be sum of all the values, right? So we can say minimum sum can be 1 and the maximum sum can be sum of all the values. Correct? Now what you will have to do, you just have to find out a mid value because your binary search actually works on the mid value, correct? So if you have to check if your mid value is the maximum sub array sum possible, what you will have to do, you will have to maintain a count. And how that count is going to help you out, that count is actually going to be the count of sub arrays, and those ones are going to include all the possible elements in the sub array unless your sum is going to be less than the mid value. All right, I'll just write it here for your reference. So what we will do to check if mid is the maximum sub array sum possible. So what you will have to do in such a case, you just have to maintain a count of sub arrays. Okay, so just maintain count of sub array. And when we are going to maintain a count of that, what we are going to actually do, we just have to maintain a possible, we just have to, when we are going to include the sub array. So if you have observed with the help of that example as well, what we were actually trying to do, so we were just trying to keep the sum of all the elements, and then we were doing all the sum of elements. What we were actually targeting, we were targeting that we are going to get a sum which is going to be the minimum one, right? So what we can say, maintain count of sub array, that includes all possible elements in the sub arrays until their sum is minimum. Correct? We can say until we are going to do that, or what we can say, until your sum is actually less than mid. Let's link it with the mid value. All right. After that, what we are going to do, after we are performing all this evaluation and all, what we will have to do, we will just have to check if your count value is less than or equal to k. Because why it is actually going to be helpful? Because if you can achieve the mid value in such a case, what we can say, okay, now with the help of that, we can find out the required sum. Correct? So I'll just write it here. So what we are going to do, we just have to do some evaluation. So I can actually just write after this evaluation, if the count is less than or equal to k, then mid is achievable or not. And why we are considering that? That is because we are going to do the partitioning based upon the mid value only. So now what we will do, I'm just going to take you to the Visual Studio Code and we are going to quickly write the program for the same. All right. I'm just going to knock off all the code which we wrote here for the previous question. So here what I will do, firstly I'm going to create a function, and what this function is going to do, this one is going to check if your mid value is the maximum sub array sum or not. Okay, I'm just going to write down that one only. So what this is going to do, function to check if the mid can be maximum subarrays sum. Alright. Here what we are going to provide, we will be providing your mid, your n and your k. What is your mid? That is the mid value. N is the total number of elements and k is the partitions which we are going to make here. Inside this, I'm just going to create a variable count, and that one I'm going to make it to 0 because we haven't started counting yet. So later on when we are going to do the evaluation, we are going to update this count. Then we are going to take some sum. Initially it is going to be 0. So whenever we have to calculate the sum, what we will have to do, just initialize it to 0, and later on whenever you are going to encounter any value, just add it there, because any number added to 0 is not going to change. It is going to remain same. Alright, after that what we are going to do, we are just going to run a loop, and that loop is going to run across all the elements of our array. Alright, after that what we are going to do, we just have to check for the mid value of this array. Okay, so here we have to pass our array as well. So in this we are just going to check against the mid value. So if this value is greater than the mid value, what you will have to do, you just have to return false, because if it is not going to be there, we cannot achieve it. Correct? Otherwise what we will be doing, we are just going to increase sum of current subarray. And how we are going to do that, whatever value you have, you just have to add the value from your array. So to your sum, you are just going to add the value from your array. Now what we will be doing, whatever we just discussed, what we are going to do, we are just going to check if your sum is going to be greater than the mid or not. If it is going to be greater than your mid, what you have to do, you just have to increment your count. Okay, so I will write it here. If the sum is greater than mid, then increase the count. Okay, and how we are going to do, we are just going to check it that if your sum is greater than mid, that is how you are going to check. In such a case, what we have to do, we have to increase the count, and after updating the count, what we are going to do, we are even going to update your sum value. So now your sum is actually going to have the value from your array. So whatever value is there, just update it to sum. Alright, after that what we are going to do, here also we are going to update the count, because we have to update your subarrays as well. After that, but we are just going to check, we are just going to check it against k, because this one is actually going to return you if you have reached to all the partitions or not. Okay, so we are just going to check if your count is less than or equal to k. In such a case, what you will be doing, you just have to return true. Otherwise, like if it is not at all going to lie in any of this condition, what you will have to do, you just have to return false from here. So this is how your check function is going to work. After that, what we are going to do, we are going to create another function, and that function is going to find out the maximum subarray sum. Okay, so now we are going to create function to find maximum subarray sum, which is minimum. This is what was given to you in the equation, right? So for this, what I will do, I'm just going to create a function solve, and here what and all I'm going to pass, I'm going to pass my array, then I'm going to pass the maximum length, and then your k value. So inside this, what I have to do, like we discussed, we are going to use the binary search. But your binary search is actually before applying to that, what we are going to do, whatever array you are going to have, that one we are going to reduce it on the basis of maximum value. Okay, so what I'm going to do for that, I'm going to use your reduce function. So I'm going to use let max, and this max is going to have whatever array value you have. On that, you just have to apply your reduce, and there I'm going to just pass on two values as the parameter, and then what I will do, I'm going to use math function, math.max, and then it is actually going to return you the value which is going to be maximum out of a and b. So that is how it is going to return the max value. Then what I will do, I'm going to create another variable that is going to be start, and initially it is going to take the value from max. So what this is actually going to do, this is going to store your maximum sub-array sum, and what it is going to consider at the same time, that your sub-array length is going to be 1. So what this is going to do, this is going to store maximum sub-array sum considering length of sub-array as 1. So this is how this is going to work. Similarly, we are going to consider another variable that is going to be end, and initially I'm going to make it as 0. So what we are actually doing, so even if you remember the example, what we were doing, we were actually analyzing it over all set of values, right? So this is what we are trying to do here as well. That is why I'm taking two different variables in order to achieve it. Now what I will do, I'm going to run a loop, and this loop is going to start from 0 till end of the array. And inside this, what we will be doing, we are just going to calculate the maximum sub-array sum. So how we will do, what we are going to do it in your end variable. So in the end variable, what I will do, whatever values we have, that one I'm going to add it there. So what this is going to do, if you remember, even I discussed minimum, if we are considering the minimum length, that has to be 1. If we are going to consider the maximum length, that has to be n. So that is what I am going to achieve it from this. Okay, so what this is going to do, this is going to return you the maximum sub-array sum considering the length as n. So if it is going to be n, what it is going to store, it is going to store sum of all the values. Right, after this, what we will be doing, we are going to store the possible maximum sub-arrays, right? So what we are going to do, we are going to create a variable answer, and answer is actually going to store possible maximum sub-array sum. All right. Initially, I'm going to mark it as 0. Then what I will do, I'm just going to check if the start is actually less than or equal to end. Then only I will keep on iterating. And what we are actually trying to achieve it from there, if you remember, we considered this partition there, right? So that is something which we are trying to achieve there with the help of start and end variable. Okay. So here I'm just going to check if your start is less than or equal to end. In such a case, what you have to do, you just have to find out your mid value. So how you can find out, mid is actually going to be sum of start and end. Why are we taking parse end? Because if you're just going to do it, it is going to return your floating value. But mid is actually going to mark as one of the index, and index cannot be negative. So in order to have a positive, a whole number as the index, what you will have to do, you just have to convert it to end, %. So % is going to convert it to ends, and then you, like let's say you are having value as 1.5. So this one is going to return you only 1. So after that, what we will be doing, we are just going to check if mid is the possible solution or not. And if that is the case, what we will be doing, we are just going to update your variable. So we are just going to check if mid is the possible solution. So if it is going to be the possible solution, what you are supposed to do in such a case, you just have to update, right? So if mid is the possible solution, so in such a case, what I'm going to do, I'm just going to check. I'm going to use this check, and here what and all we are passing, you are passing your array, your mid, your n, and your k. So all those parameters, we are going to pass it to that function if that is going to return you true. So in such a case, your answer is actually going to be equal to mid. And then your end is actually going to be mid minus 1. That is how we are going to update your partitions, right? Otherwise, what we are going to do, we have to update your start partition. And what it is doing, if you remember how we were making the partition, so in one of the partition we just considered 1, in other partition we consider like in first one 2 values only we'll consider, that was 3 and 4, then it was 2 and 3. then it was 1 and 2. So that is how we were considering the various partitions, right? So that is how I'm going to update the indexes for that. I'm going to update the sums for that. Okay, and in this one, your sum is actually going, your answer is actually going to store all the values. So that one we can just return. And here, you know what we can do? Now it is better, right? And this answer we are updating here. And at the end, what we will do, we are just going to return back this answer. Later on, what we will do, we are just going to create one array. So let your array is there. To that, I'm going to pass 1, 2, 3, 4. And after passing those values, what I will be doing, I'm just going to calculate its length. That is going to be this array dot length, and I'm going to pass it on the k partitions, and then what I will do, I'm just going to call this function, and this was solve. And what and all it was expecting, array n and k. So now if we will run, you can see the output for the same. Okay, it is still running.